In this video lecture, we will understand about nucleophilic substitution SN1 SN2 reaction. First of all, SN2, that is substitution nucleophilic bimolecular reaction. First of all, remember this type of reaction takes place in one step. So, here the reaction is substitution of halide by nucleophile. Now let's see mechanism of reaction. Now the reaction takes place in one step. So, first of all, movement of leaving group from molecule starts. Leaving group starts to separate out from reactant molecule, and negatively charged nucleophile approaches towards molecule from opposite or rear side. Both the steps takes place simultaneously, and we have a condition in which old bonds starts to break and new bonds starts to form, and this condition is called as transition state or activated complex. And finally, we have our product in which nucleophile takes its position on the molecule. So the overall reaction takes place in one step only. Students, try to understand few more points. As we are seeing in reactant molecule, the group X, that is leaving group, is present towards right hand side, and in the product nucleophilic group present on left hand side. Now we can say this type of reaction result in inversion of configuration. If initial molecule possess R configuration, then final molecule possess S configuration, and this inversion of configuration is also called as Walden inversion. Now, such type of reactions which takes place only in one step are also called as concerted reactions. Now students, from rate law we can say that rate of a chemical reaction directly proportional to concentration of those reactants which are present in slowest step. Since the reaction is taking place only in one step, so we can say rate of such reaction depends upon both the reactants, means reactant as well as nucleophile. So the rate of this reaction depends upon two concentration terms, and that is why the reaction is called as SN2 or bimolecular reaction. The order and molecularity of reaction is 2. Now let's understand factors affecting SN2 reaction. First factor is SN2 reaction is inversely proportional to stability of carbocation. Second factor, more heavier is the group, higher is the tendency of SN2 reaction. And the last factor, but most important factor, is SN2 is inversely proportional to steric hindrance effect. Let's solve one question. Which out of these two species will undergo SN2 at faster and preferable rate? So remember, first factor, lesser is the stability of carbocation formed higher is the SN2 reaction. Second species possess resonance stabilized carbocation which is more stable, hence we can say the first species has higher tendency to undergo SN2 reactions. SN1 reaction, substitution nucleophilic unimolecular reactions. Such reaction takes place in two steps. Now the reaction is. Now let's check the mechanism of this reaction. Now in first step, removal of leaving group takes place, resulting in the formation of carbocation. Carbocation thus possess planar structure and nucleophile can attack from front side as well as from rear side. So we can have two products, one with retention of configuration as that of initial reactant and second with inversion of configuration as compared to initial reactants. So we can say retention as well as inversion of configuration. If initial compound possess R configuration, then in the final product we have R as well as S configuration. Now, such type of mixture is also called as racemic mixture. So this is the one of the important aspect of SN1 reaction, that it results in formation of racemic mixture. Also understand, the first step is slowest step and the second step is fast step. So according to rate law, we can say rate of reaction is directly proportional to concentration of reactants present in slowest step. Since slowest step possess only one reactant, so we can say rate directly proportional to concentration of reactant, that is alkyl halide. So the order of reaction is 1 and that is why the reaction is SN1 reaction. Now let's understand factors affecting SN1 reaction. First factor, SN1 is directly proportional to stability of carbocation. Factor 2, SN1 directly proportional to polarity of solvent. SN1 directly proportional to heavier group or tendency to leave of leaving group. And last but most important factor is SN1 directly proportional to steric hindrance effect. Now let's solve one question. Which out of following has higher tendency to undergo SN1 reaction? So according to first factor, the species which form stable carbocation possess higher tendency to undergo SN1 reaction. So second species form resonance stabilized carbocation, hence it possess higher tendency of SN1 reaction.